But if I'm dealing with limits that are getting to be infinity or 0, remember, it only works, infinity only works with divergence, 0 only works with convergence, because I think, Aryan, you were saying basically direct comparison test applied, sort of. Sorry, I'll give you guys some more time. I just wanted to, just in case you were still trying the direct comparison, not that that's awful, not that that's horrible, it's just, it's dangerous. Just be careful. Because it might work in one, but then it might fail in another one. Bigger doesn't always show divergence. Yeah.
The condition where it's L equals 0, B converges is the opposite truth. If BK diverges, so if this diverges, then does this diverge?
No, only if the limit's infinity. Does that make sense? It's that whole idea of smaller, bigger as to who's winning. Does that make sense? Yes.
So if I did the limit test of this one, and then
But careful, isn't ln to the 3/2, isn't that convergent? Infinity with convergent shows nothing.
yeah, so that's what I was asking. So
Oh, it shows nothing. Right. We can try that, but it just doesn't work. Because if the limit's infinity according to limit comparison, I need a divergent to show divergence. Otherwise, it's like instead of smaller pushing out, if the limit is 0, your bigger doesn't tell me anything about him.
Wait, which goes faster?
What, Justin?
N to 3/2 grows faster than N, right?
Yeah. Because the degree is 1.5 instead of 1.
So wait, what are you about to compare it to? Just 1 over N or?
Well, the problem, 1 over n, you could. Guys, there's a great discussion with number 4. How many of you guys have figured out number 4? It's a hard one. All right. If you guys don't mind, let's do a full class discussion on what you've discovered for number 4. Because it's a beast. Maybe. It lets you know how to get to know the test. So Justin up here is saying, okay, so n to the 3/2, like n to the 3/2. Okay, what are you going to compare to? 1 over n. Let's think ahead, right? Because we have to think ahead. And we're starting to kind of do mental math with convergence, divergence. 1 over n diverges p series p equals 1, right? Okay. If I take the limit, n times ln of n, is that weaker or stronger than n to the 3/2 if we were to do L'Hopital's? Do you know? Yeah, why is it weaker? Who's stronger? No. Hold on. N times ln of n. Couldn't we rewrite this to be n times root n? Who's stronger, root n or ln? Yeah. So bottom wins. So what will the limit be if I compare to 1 over n? Why do I know nothing?
oh, because it's a divergent series.
Divergent series with a limit equaling 0, I know nothing. So therefore, good try doesn't work. Now I heard this group over here, you were comparing to 1 over n to the 3/2, right? Okay. So if you compare to 1 over n to the 3/2, oh yay, it's a convergent. So I can get a 0 now, right? But what happens if I take the limit? Those are tied. ln goes to infinity. The limit's infinity of a convergent. I know nothing. Here's where the little trick I showed yesterday with the addition that I shouldn't have done, multiplication, comes in handy. How about 5/4? It's not n to the 1, which diverges. It's not n to the 3/2, which converges. It's in between. And what kind of series is 1 over n to the 5/4? Converge. Hold on, let's take the limit. We can say, since the terms are positive, just reminding you, this only works with positive terms. And, okay, now it's time for the limit. The limit as n goes to infinity of, all right, hold on. What's going to happen if we compare? Don't just guess. We've been kind of guessing up until now, but you've been right. Is it infinity or is it 0? Top wins? can't I do n times the fourth root of n times ln on the top, right? And on the bottom, n times square root of n times ln of n. Wait a minute. Root of n in terms of the fourth root. Wouldn't that be 2 fourth roots? Sorry, there's no ln of n in the bottom, is there? Okay, does that work? Because 1/4 plus 1/4 is 1/2, right? 1.5. What am I doing? I'm trying to have you guys narrow down. There are the n's. There are the fourth root. What are we comparing? The fourth root with the ln of n. What else could we have done? L'Hopital's with product rules. We could have. We could have taken a derivative of n to the 5/4 ln of n. If you really want to, you can. You could also say, like, hold on. Isn't that going to reduce away, reduce away? Okay, who's stronger, ln of n or the fourth root of n? Now do L'Hopital's, right? L'Hopital's, this is going to be 1 over n to the 3/4. Pop that up on top, n to the 3/4. But who's he? 1 over n. Aha! The limit will be 0. Yeah. It's perfect. Why? It was bad when the limit was 0 when I was comparing with a divergent series, but it's perfect if the limit is 0 and I'm comparing to a convergent series. Because, check it, wasn't he on top and he on bottom? If the limit is 0, that means the bottom is stronger, he stronger, bigger, converges. Booyah, I got it. Or just memorize the limit comparison test and be like, 0, converge. So how am I going to finish this puppy off? Since the terms are positive and the limit is 0. And the series of 1 over n to the 5/4 converges, P series, P equals 5/4, which is greater than 1. My series converges as well. How? Limit comparison test. Probably we should. Like for you, for the test, you need to be like, oh, hey, I've done this. So on the test itself, when you guys are taking it eventually after section 9.6, ooh, it's coming. Love you all. You will need to start off every single justification as by the blank test, because that's my way of saying, oh, you're doing this test? Cool. I'll mark off your P. I'll mark off your R. I'll mark off your T. Does that make sense? But you can shortcut it and be like, by limit comp. Cool. Nice. I knew I liked this book sometimes. Yeah. I forgot that it was in there. It's been a couple years since I picked out the problems, but that's perfect. Okay. True, you have to use one twice. Choose which one is your favorite. All right, you guys just good with us finishing this guy off? Is that okay? How many of you guys are on the grade homework right now? Okay. I'm going to get the evens on the video, and then if you guys have quick questions, we'll do it, but we're not going to spend tons of time with the rest of questions on Monday when everyone else is ready to catch up. Sound good? Number 5. What are you guys seeing as you look at it? Am I smiling? Top wins from the very beginning? Top wins? Is that good if top wins from the very beginning? Top wins? What test? Divergence test. What can I say right away? Oh, hey. The limit as n goes to infinity of, forget this guy. Top wins. Why am I even worrying about him? He doesn't equal 0. Therefore,
That's the best one.
but it only works every now and then, right? It's the best one. Oh, it sucks. Well, this is a term test, right? What could we have compared it to? I don't know. Anything you wanted to, basically. The top's going to keep on winning no matter what. But I guess you could have compared it to, well, unless you did 1 over 2 to the n. No, 2 to the n. I think I probably would have compared, if I hadn't thought about it, I probably would have compared n over n cubed to 1 over n squared. And then those would have tied, and then it goes to infinity. Infinity and convergent wouldn't tell me anything. Anyway, you could get lost in a rabbit hole in this one if you didn't just see divergence tests here. Wait, pause one more time. So hold on, why didn't we do that here? Because this guy diverged. Why didn't we do it here? Well, divergence test. Why didn't we just use the divergence test here? This guy diverges. What's the limit as n goes to infinity? 0. Oh, we know nothing. Could converge, could diverge. We don't even know. Just reminding you, we know nothing if the limit equals 0. So let me go ahead and show you guys. Well, let me get you writing on section 9. Oh, is that the one we just did?
You know what you should add to the grammar penalty?
Huh.
So when it says we know nothing, you should put try another test.
Oh, so don't just stop. Poor Maggie on her quiz. Sorry. We know nothing. Keep going. We know nothing. Try again. We know nothing. Don't stop. Believe in. Anyway, so. Thanks. That has a mission meeting today. So sad. First good club. What's our theme for the month?
It's Disney.
That's sad. Just not today. And choir kids are gone today.
Yeah, I'm just gonna play Disney music.
Nice. And it can be like a planning. You guys can talk about what you want to do.
We'll just sing karaoke with Disney music.
Nice. You're going to bring in Georgie's speaker and we could just... You don't have to.
I have my karaoke mic.
Because we could like have Glee Club outside and could, like singing and dancing and frolicking in the when it's not cold anymore.
Yes.
Where's mine?
All right, let me pause the video really quickly. Let me pause the screen so that you guys can get down like that. I never
I was
addressed
just
you.
like, is anyone else going to say anything? No.
Okay, so here are the evens. Number 24 was diverges, 26 was converges, 28 was converges, and 30 was converges. Maggie, you said 10. You didn't have 10, did you?
No, I meant 9 and 11.
Oh, 9 and 11. Got it.
Questions on.
Diverges, converges, converges, converges.
Oh, whoa, wait. I'm sorry.
No, you're okay. It's the 24 through 30 or whatever those ones are.
Yeah, I just want to check them. Because I wrote those paragraphs so I can fill this and I got to find my answer.
Oh, got it. Converge, telescoping. Converge, telescoping again.
Oh, I didn't use telescope.
I don't know how I knew it. I wrote
I used limit
converge,
comparison for that one.
telescope,
Oh, you could do limit comparison.
28.
So I did.
Maybe you thought about them canceling out, and then you're like, oh, it's going to go to 0.
But I don't know how to do telescope, so I just wrote converge.
Okay. Let me get rid of those. Zoop, 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 zoop. Let me go back
The
here.
same ones they did, right?
Zoop, zoop, zoop. Huh?
You don't have to use the same ones they did.
Not necessarily. Just make sure you're using them right. But yeah. I had number 49 ready, but since you guys weren't necessarily like asking for it, I will peek at numbers 9 and 11 if we have time.
49?
Well, how did?
45.
You guys didn't have 49?
But that's a 9.4.
Oh, homework 49. Sorry, number 7. Lo siento. I had number 7 from homework 49. I'm sorry.
Yeah, there it is.
Yeah. Was that like your 9 and 11 that you got stuck on?
No, this is number 7.
Oh. Can you guys peek at this one with me really quickly before we go to alternating series test? Don't worry, we're going to have a couple of days for alternating. Why am I highlighting this one? I thought it was a homework question at first, but I'm like, oh, actually, it's not that bad. Can't we just compare it to, once you know the limit comparison test, couldn't we just compare it to 1 over n, which diverges p series p equals 1. When I multiply, it'd be n over n. Ooh, but what's the limit as he goes to infinity? Sorry. If I compare to 1 over n, I'm doing mental math, I apologize. If I compare to 1 over n, I multiply. N over 1. Those degrees match. Top is stronger. So what's the limit to infinity if I compare to 1 over n? Infinity. Infinity, divergence, I'm done. But what test did I tell you to use? What would you compare to?
1 over n plus 1.
Okay. So if we compare 2, what's the relationship between 1 over n plus 1 and ln of n over n plus 1? Now, what do you hope the relationship is? Do you guys know who this is? You can't use p-series exactly. I mean, you can indirectly. You compare smaller, bigger diverges. You could use integral test. Whew, there we go. Because the integral would be ln of going to infinity is infinity. There you go. Okay, so improper integral, we could say that diverges. But what's the relationship here? Well, wait, if it's divergent, what do we hope that it is? Otherwise, we're in trouble. We hope that it's smaller, but is it truly? If we were to plug in and do the first few terms, wouldn't that guy plugging in 1, wouldn't that be 1/2 plugging in 2, 1/3, 1/4? This one, if I plug in 1, I would get 0 plus, oh, whew, Aryan just brought up that it starts at 2, not at 1. It's okay. Whew, that wasn't even a part. So maybe we're good, right? Okay, so now plug in 2. So ln of 2 over 2 plus 1 is 3. ln of 3 all over 3 plus 1 is 4 plus calculator time. What's ln of 2 over 3? I'm just asking. E is 2.71828 and it hits at 1. I might not know ln of 2, but I sure know that he's somewhere in between 0 and 1. He's a 0.9, 0.8, 0.7? Yeah. What's ln? 0.231? Yeah, no it is, because the 1 is really high. So it'd actually be like down here somewhere. So it's 0.2 something. Wait, what's 0.2 something over 3? 1/5ish over 1/3ish? Isn't that 1/15ish? He's not bigger.
Oh, so the integral test doesn't. Wait.
Wait, did she? What happened to me?
We're comparing 1 over n squared to
Oh.
ln over n squared, and then Arya were like, well, 1 over n squared is going to be small. Because it's not multiplied by anything. And then I was like, I think it's the other way. And then I got all confused in my head.
Wait, what's our
Yeah, what is ln of 3?
1.09?
Okay, and then 1.09 divided by 4 would be bigger, right? Because 1.09 over 4 compared to 1 over 4. Okay, this one is bigger. But what was not? Wait, will it keep on being bigger forever? Yes. Like you can keep on plugging in. It's going to be bigger forever. So is this valid? Yes, but only for n greater than 2. So what do we do? Remember I said the forever is what matters? We could rewrite this guy, couldn't we, to be, well, not even that. Let's just do this. Couldn't we rewrite this guy to be, isn't this just a sum anyway? So couldn't we just go from 3 to infinity of ln of n over n plus 1 and figure out his convergence or divergence and then say, wait, what was 2? Oh, ln of 2 over 2 plus 1 is, I'm just going to separate him. He's not truly bigger. So I'm just going to write him off to the side. This is still that. But this guy didn't actually fit my test, and so I'm like, okay, well, the forever is what I care about. That's whose convergence or divergence I care about. If that converges plus a constant, the whole thing converges. If that diverges plus a constant, the whole thing diverges. So I can't write equals. This can't equal that. I can't just ignore the first term because then my test fails, but I can separate and say, oh, but the test works for this. Now I can say compare. Oh, hey, ln of n over n plus 1 is going to be greater than 1 over n plus 1 for this series. Does that make sense? So then I can go ahead and do my direct comparison now, saying, oh yeah, if that's always greater than that, then okay, we can go ahead and do the direct comparison. Since that diverges, that plus a divergent plus a constant diverges, I'm done. Dun, 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 dun. See what I mean by something could start off failing a test, but then to forever it passes the test, so all I worry about is the forever. But I can't I couldn't write like an equals. We'd have to be careful about not having a lapse in our argument. But besides that, we're okay. Yeah.
This is kind of off topic, but it's something you mentioned. So
Yeah.
like, when you compare to something like from 1 over n plus 1,
Yeah.
is there ever going to be a thing where it's like you have to do a direct comparison on the direct comparison assumption type?
No, it would just be a way of finding the convergence or divergence of what you're comparing to.
So if you had to do that,
It wouldn't be, I wouldn't say a preferred way.
so would you have to like write the whole thing, like the whole description?
Yeah. If that was the way that you were choosing to do it. Yeah. I mean, a shortened version with like abbreviations and things. But. All right, alternating. What's going on? Endeavor, number. Oh, yeah, because we added telescoping. Is that right? 19 was limit comparison, I think. Okay. Guess what? We finally get a whole section for one test. Is that good or bad? Well, we're going to take a couple of days on it, so we don't have to get the entire test figured out. But you are seeing the entire test now, so what's going on? The alternating series from 1 to why do I have two? Sorry. Can you guys add a +1 right here? Oh, stink. I always do this and it always looks nasty. -1 to the n or negative n to the -1 to the n plus 1. What this is showing is it can start off negative or it can start off positive. The main point is that it's alternating. So this one, if you plug in, and it could also like start at 2 or start at 3, but if you start at 1, it's going to start negative, then positive, then negative, then positive. Or whether it starts off 1 plus 1 is even, so that'd be a positive, positive, negative, positive, negative. There's no bearing on the result. So as long as it's alternating, whether it's starting negative or whether it's starting positive, these alternating series will converge if these two are true. Limit as n goes to infinity. Hey, we know nothing. Well, it actually is really important to knowing something. Oh, we've already known that though, right? If the limit is 0, forget it. Converge test, we stop. If the limit does equal 0, at least it's possible to converge. We only need one extra step besides that. All we need to show is that the the sequence of terms is decreasing, right? Because if every n plus 1 term is lower than the one before, lower or equal to, oh, maybe not decreasing, decreasing or equal to. All right, what's up?
In the first series, doesn't it say n minus 1? So then don't you not do that?
Oh, sorry. The equals got lost in, yeah. Sometimes in PDFs, little bits and pieces get lost. I don't know why. It's like fragments I don't know. So long story short, the terms need to alternate in sign. The alternating series will converge if the terms eventually are decreasing. Why am I saying eventually? There can be a little fluctuation, but what do I need? I could separate out all of the fluctuation. I could start my series at whatever bound to forever that it then decreases. Does that make sense, like you just saw me do? I can separate the terms and say, okay, forget the first 3. I mean, don't forget them, write them, but then plus sigma, haha, you are decreasing, ha. I'll test you. So I can separate. It may take a while to do so. Write out the first few terms to make sure that you're doing it legally. But here's something extra. Here's something extra with alternating series. There is an extra characteristic description of an alternating series. Absolute versus conditional convergence. This is only a thing for alternating series, where we even talk about absolute versus conditional. But guys, just think about the words absolute versus conditional. Now, if you're in like a philosophy class, or hopefully at least having gone through some of the Bible classes here at school, you've talked about absolute versus conditional, well, absolute and relative truth, and the debate and the argument, and how that worldview can drastically affect how you live your life, decisions that you make, etc., your perspective. Are there absolutes? But absolute versus conditional convergence. Absolute is like absolutely no matter what. Usually the one that everyone brings up is like lying. Is lying always wrong? And they usually bring up the Corrie ten Boom example of she had Jews hiding under a table. The Nazi soldiers came in and said, "Are you hiding Jews?" She said, "Yeah, they're right under my table." And they were. And they left. They were like, whatever. And they were like, God worked a miracle. They didn't think about it. They thought she was kidding, whatever. People bring that example up. But then there are plenty of examples where the outcome was not optimal when the truth was told. So anyway, absolutely. We're not going into that debate. Although this is an important one for you to consider. But absolutely, no matter what. Conditional, based on a condition. Hey, alternating series. Why is it called an alternating series? Because it's a series with an alternator. Alternator in your car has the current, if I'm right, and I might be wrong, James, you might know better, it fluctuates the current so that it doesn't wear out your battery as quickly. Because if you had a straight, I don't know if charge is the right word, but if the battery was always pouring out in a straight current, it would wear down much quicker. The alternator alternates. Has to do with electricity. I didn't go that far in physics. But anyway, it's the basic idea. So alternating series, it has a negative 1 to the power of n, or a negative 1 to the power of something, or it has a sine of pi n, which would also a cosine of pi n would alternate. Why? Positive 1, negative 1, positive 1, negative 1. There are different things that can make a series alternate, positive, negative, or negative, positive. But here's the long story short. If the series only converges because there's an alternator, that's conditional. If the series converges only because there's an alternator, if the alternator was not there, it would diverge 1 over n. Negative 1 to the n over n converges, but only because of the alternator. If a series converges only because of the alternator, it's conditional convergence. If it would converge whether or not there was an alternator, absolute convergence. And so look at the test. Look at how we tell what's going on. Absolutely says regardless of the sign. Absolutely says think about the absolute value, disregard the alternator, basically. Disregard the alternator. And so as we practice this, you guys might come up with your own way as to what you want to check first. Do you want to check the absolute value function first and then deal with him? Because if the absolute value function converges, you're like, oh, sweet, the whole thing converges. Absolute convergence done. But if the absolute value diverges, now you have to go looking at the at the alternator and say, but does he still converge conditionally? Or you can go for the conditional convergence first and take the alternator, whoever he is, and be like, hey, do you converge? Sweet. Absolutely converge. I don't know. I have to go looking at the absolute value. It just depends on the one as to which way would be easier, faster. And my point is not necessarily to make this easier or faster, but to make you able to do the test. So this is endeavor number 21. If I were you, I would make a quick little note that this is only for alternating series. I mean, it's right after the alternating series test. But only alternating series do we qualify whether it's absolute or conditional when it converges. The strategies for testing, if I were you guys, I would just leave a blank for each line because it's going to take us getting into and practicing. I could tell you stuff now, but I basically just did, but I'm not sure if it's going to really help. So let's go ahead and get in and play. Do you guys see him alternating? I do. As soon as he's alternating, all we need to do is take the limit as n goes to infinity of the absolute value of this guy, which basically is just the limit as n goes to infinity of 1 over n, which is 0. The sequence of terms is 0. And what happens as we plug into the terms themselves? The absolute value of 1 over n is equal to 1 over 1 plus 1 over 2 plus 1 over 3 plus... What happens with a sub n plus 1 versus a sub n? What's going on with the terms if you disregard the sign? Aren't they always decreasing? So therefore, series converges, but why am I going to put conditionally to end us off today? Take away the alternator, and what do we know about 1 over n? Diverges. It's only conditional. It's only convergent because of the alternator. All right, cool kids. Get out of here. Catch up. Please catch up. Catch up on section 9.4 and 9.3 and 9.2. Have them ready to go because next week it's going to be a full week because we finished off our convergence divergence test. check out the calendar if you're worried. Bye, guys.